Now let us understand the concept of concurrency of three lines. Now if you consider two lines in a plane which are say intersecting each other at some point, right? Now if there is a third line that also lies in the plane, what are the different possibilities of that line with respect to these two lines? Right? Now it may happen that the third line intersects those two lines in two distinct points like this. So basically they form a triangle, isn't it? That is one possibility. But there is another possibility also, that is these are the two intersecting lines to a point. It may happen that the third line also passes through the same point through which the other two lines are passing. Right? So this is a special case, and this special case is called as concurrency of three lines. So when we say that the three lines are concurrent, what it means is all of them pass through the same single unique point, right? Now the question automatically comes that if we know the equations of the three lines, right, without drawing them on the graph, how can we detect whether they are concurrent or not? So let us try to find a condition. Now this is a necessary condition for concurrency of three lines. So by the word necessary, it means that if the three lines are concurrent, then which condition they will definitely satisfy. Now to develop the condition, let us consider the three concurrent lines whose general equations are given. Okay, what we do is, first let us consider only the two lines, any two lines of our choice, and we solve these two equations simultaneously so that we get their point of intersection, which we have seen earlier. That is how to find the point of intersection of any two lines. Now if the lines are concurrent, that means the point that we have obtained so far must satisfy the equation of the third line also, right? So whatever values we have got for x and y, which are in terms of a1 a2 b1 b2 and c1 c2, right, those values we substitute in the third equation, and hence we get a relation between all the a's, b's and c's, right? So that relation when simplified gives us a final simplified form as a determinant as shown here. So the determinant a1 b1 c1, a2 b2 c2 and a3 b3 c3 must be equal to 0. So that's the necessary condition for the lines to be concurrent. So once again, just to clarify the meaning of the word necessary condition, it means that if the lines are concurrent, then this particular determinant is 0. But the converse is not always true. That means this condition is not sufficient. So what it means is, if determinant is equal to 0, then that does not imply necessarily that the lines are concurrent, for a very simple reason that the determinant of these coefficients can become 0 due to some other reasons also. That is, out of the three lines, if say two lines are parallel to each other, then their ratios will be in the same format. So therefore in that case we may get the determinant 0, but yet the lines are not concurrent, right? Let's solve one sum based on this condition for concurrency. Now here we have to find the value of k so that the lines given by these three equations intersect at a point. So by intersect at a point, we mean they are concurrent at the same point, right? So if you want the lines to be concurrent at a point, then we have to argue that the determinant formed by their coefficients and the constant terms must be 0, right? So for the first line we write the coefficients as 3, 1 and minus 2, right? 3, 1 and minus 2. For the second line we have k, 2 and minus 3, and for the last line we have 2, minus 1 and minus 3. Therefore on expanding the determinant, we have 3 multiplied by the product of 2 into minus 3 minus product of minus 1 into minus 3, So that turns out to be minus 6 minus 3. Then next sign is always minus. So now we take the second element in the first row. Now here we do the cross products of the distant terms, that is k into minus 3 and 2 into minus 3. So that gives us minus 3k plus 6, and last term in the first row as it is, that is minus 2 multiplied by. Now we do once again the cross products as shown here, which give us minus k minus 4 equal to 0. Okay. So therefore on simplifying we get 3 into minus 9 is minus 27 plus 3k minus 6 plus 2k plus 8 is equal to 0. Now on solving this we get k equal to 5. So that's the solution.